And welcome to the Daily Space Weather, folks. Looking at the Sun in 94 angstroms, we are still in geomagnetic unrest conditions. KP index was 4 last I checked. One of the reasons we use the 94 angstroms view here to look at the Sun, folks, is because this takes 10 photographs per minute instead of only 2, so 5 times as many photos as the other scopes. With the exception of 131 angstroms, these two scopes, 131 and 94 angstroms, take more photos to further analyze solar flare activity, sunspots, and so on. Anyway, there's 48 hours of the local yellow dwarf. No sunspots. Large coronal hole in the south. We're going to talk about it in a minute. Here's the 304 angstroms view, and some filamentary activity there up in the northeast. Let's full screen it. And there's a full screen view, 48 hours in 304 angstroms. And next we made a helio viewer movie here, looking close up of the South Pole coronal hole. A little bit of sputtering activity going on down there. And the South Polar field is looking strong. We'll get to it in a minute. First we'll look at helio viewer and show you the fields to show there's not a lot of magnetic organization happening there. A little bit around this coronal hole in the east. Couple little spots of magnetic organization, but again, no sunspots. Pretty low levels of solar activity. And we're going to look at more data. First, let's talk about smAsho.org. Have you visited it yet? Well, if not, we'd like to welcome you to the Neo-Renaissance, as large swaths of science get rewritten so fast we can barely keep track. So check it out, smAsho.org. Scroll down, click on the link to the newly unveiled smAsho forum, or just type in smashomash.com/forum. As we've got all kinds of different topics there, and let's give you a quick little blurb. Check out the free-for-all forum if you're interested in the virus. The blank virus. We've now got 5 pages of information on it, including this most recent post showing you the supply chain risks on one simple graphic. So again, check out smashomash.com/forum. A massive repository of information being updated daily. And thanks everybody for joining. Please feel free to create your own topics. Talk about whatever you want. We will not censor you. And there's the KP index. You can see it made it up to 5 there for a brief period of time. Back down to 4 geomagnetic unrest conditions. 10.7 centimeter radio flux is still at 71. Barely off of solar minimum conditions. And we see a little bit of X-ray happening there, so that's something to keep an eye on throughout the day. And when I say eye on, our regular viewers know that the pun is intentional. Now I'd like to talk about the BT-BZ for a quick second, as the BT got all the way up to 12. 12.7 it looks like there for a while yesterday. And the BZ was all the way at -12. So that's one of the biggest divergences there we've seen in the BT-BZ. If you don't know what that is, the BT is the total field strength of the Sun's B field, the interplanetary magnetic field on which you live. And the BZ component is the proportional aspect of that field coming from the pole. So when you see a -12 BZ, that is a very strong influence of the south solar polar field. And again, that entire graph got expanded yesterday. So you can see it's going all the way up to 15 now, because we saw some very, very high readings, and then some subsiding of that, and then some more high readings and a shifting of the phi angle at the same time. Hopefully that helped you understand the measurements of the solar polar fields and the total field strength in that top pane, the black and red lines. Next, the phi angle is a measurement of the orientation of the incoming plasma, a completely different thing, and the current orientation is 267 degrees. And we see a precipitous drop down here in solar wind density, currently at 2.27 protons per cubic centimeter. That's quite a low solar minimum style solar wind density. Solar wind speed looks like it may have peaked there at around 475 kilometers a second, now down to 468 kilometers a second. And we're expecting to see this geomagnetic unrest subside throughout the day. There's the data from ACE, looking corroborative. And next we'll look at the Geospace Magnetosphere movie. And we showed our patrons this yesterday in the afternoon, as we noticed from our automated alerts from NOAA that we were in geomagnetic storm conditions for a while. And you can see the very uniform magnetohydrodynamic pressure here surrounding the planet in geospace, looking smoother than it did yesterday. Next we'll look at ground geospace magnetic perturbations. And there we see those continued pulses coming out just south of Hawaii, as well as the Canadian North Pole looks like it's creeping southwest. The South Pole looks like it's creeping northeast towards southwest Australia during this geomagnetic excursion. Little aside, please consider becoming a patron. There are only 2 membership levels. And thanks to our latest patron, look for more information coming. Patrons get all of our information before everybody else, as Patreon is the main source of funding for our entire operation here. And also, if you enjoy the content, please don't forget to press like and subscribe on YouTube. And yes, we are planning a 1,500 subscriber spectacular celebration. Also, check us out on BitChute. Thanks to all of our subscribers over there. There will be constant exclusive content coming out. So look for all kinds of BitChute exclusives, talking about everything from dumpster fire train wrecks to other things that I'm not going to get transcribed by Google on this video. Next, we'll look at the aurora forecasts. Shout out to Brett in Alaska. Thanks everybody for leaving comments. There are the aurora forecasts. Looks like things are calming down here. And let's just hit refresh to show you the current image. There's the current auroral oval, or at least the expectation of it, as this is another model. Next, we see continued spikiness on the GOES magnetometer, as I've been forecasting day in and day out. If you know anybody else who's able to forecast the magnetic environment, please send them our way, because I'll be very interested. Next, looking at the Gong 2, more magnetic data. Looking at the heliospheric current sheet, which is almost entirely charged up by the South Pole here shown in red. Keep in mind the data is an hour and 44 minutes old, and the magnetic environment can change with absolutely no warning. Here's the latest image, and it looks like the activity causing this North Pole charge up of the current sheet is subsiding as it rotates into the opposite facing portion of the Earth-facing region. Opposite the Earth-facing, yeah, you get the idea. And we are expecting the magnetometer to smooth out now for the next day or two. And we're not going to explain why. Relativistic electrons have dipped down to quite low levels now, as we typically see after a coronal hole wind stream, again, which is subsiding now. So we see the non-relativistic electrons here, the greater than or equal to 2 mega electron volts, are also cratered at very low levels. And next we'll look at the ionosphere map. This is 6 hours of data, courtesy Government of Australia Bureau of Meteorology. And we see some South Pacific anomalies once again, areas west of South America charging up at nighttime, and some significant charge ups and charge disparities happening over the noontime portion, making it all the way up to 14 megahertz there. As the sun presses down on the ionosphere. And let's bring up the latest image. And there's the latest image at 10:15 Universal Time. Next we're going to do an earthquake rundown. And let's see what happened in the past 24. Some extreme deep quakes. First, this one in Tajikistan, a 4.8 magnitude at 128.4 kilometers depth. Followed only a half an hour or so later by this very deep quake at 405 kilometers near Sigave, Wallis, and Futuna, near Fiji and Tonga. So that 4.7, very deep quake. And let's just scroll up the list here. Saw 3.9 in Texas. Please leave a comment if you felt that quake. There's one that's close to the blot echo range there. Western South America still experiencing deep quakes, several per week. That 4.5 magnitude at 84.8 kilometers depth. There's a legit deep quake, 131 kilometers at Chile, close to the last one we reported. 4.1 magnitude, 131.5 kilometers depth. So, big earthquake drought actually right now, folks. Here's another extremely shallow quake at California. That one happening at 1,800 meters above sea level. Likely magmatic activity. And last but not least, coming in as we did show prep, a 4.7 at depth at Indonesia. Lots of deep quakes kicking off there. Please have an earthquake plan if you're in an earthquake-prone region, and be an asset, not a liability, in the event of a disaster. Speaking of disasters, we got the volcano list, which now includes Abico, flight level 7,000 there. Mount Aso, flight level 6,000 there. Sakurajima exploding, flight level 9,000 there. Suwanosejima, flight level 6,000 there. Popocatépetl exploding, flight level 22,000. Fuego exploding, flight level 15,000. Nevado del Ruiz exploding, flight level 19,000. Revenador exploding, flight level 15,000. Sabancaya, unable to detect. Please don't pitch a tent on the lower slopes of Sabancaya, as it could kill you. And Nevados de Chilean exploding, producing a 13,000-foot ash plume. Please do not attempt to pole vault the caldera at Nevados de Chilean. Here's where things are in the solar system. As Mercury swings around to blow past us like we're standing still. There's where things will be in 1 week, as Venus comes through to make a pass as well. And we're seeing Mars and the Moon very close to each other, rising just before Jupiter and Saturn. So another cosmic pile-up, folks. I like to use in-the-sky.org to make sky charts for myself. Where were you when Cygnus rose? You can animate the chart. And if you've got a telescope, get some images of Mars and the Moon. We'll feature it. Let's talk about climate change real quick. Guess what? We're in the third winter in the Northern Hemisphere, where the snowfall is 2 standard deviations above the 30-year average. I don't know if you're aware of the way glaciers form. Folks, the way glaciers form is snow falls, never melts, and then more snow falls, and that creates a positive feedback mechanism caused by the Earth's albedo effect. When light and heat are reflected back into space, that's a real positive feedback mechanism that is deadly to civilizations since the history of mankind. If you think it's getting warmer, how come so much snow keeps falling in the Northern Hemisphere year after year? Let's look at windy.com's pressure maps. And the U.S. is almost completely dominated by high pressure here, which hopefully is going to push all this moisture out into the ocean and bring us some cold temperatures here before winter is completely over. Let's animate the map. This is the GFS forecast, folks. We're going to let this go through about 24 hours here. We usually pause it at 12 o'clock Universal Time the next day. And there's where things will be around then. Next, we're always interested in where the lightning is striking. And check it out, Australia's getting struck again. Brisbane, there could be thunder rolling in. Anyway, check out lightningmaps.org the next time you hear thunder, as it could save your bacon. And we just had a stray strike in Tennessee. David Dubine, give me a ring. Next, we'll look at the U.S. Doppler radar map as we get into our value-added services. And all that moisture is going to slowly be pushed out to sea here. Some snow still falling in the Midwest. Next we'll look at jet streams here on Null School. And there you see doubled and tripled up jet streams in the northern hemisphere. Extreme meridional jet stream flow, making two 180-degree turns over as many thousand miles. And there is the eastern world's jet streams. Next we'll look at water vapor maps. First of Europe and Africa. And congratulations to anybody who's realized that dry air is more massive than moist air. It is a major breakthrough once you understand that, as you'll be able to read a water vapor map and understand what the weather's actually doing. Anyway, there's Europe and Africa. Next we'll look at the U.S. And there's the U.S. water vapor map. We're going to do a close-up of my location, which is Lehigh Valley, Pennsylvania, located right about where the pointer is there. West of Easton, Pennsylvania, and Phillipsburg, New Jersey. Let's zoom in on the dry air that's pushing through Pennsylvania. And again, we're located in Lehigh Valley. And it looks like we're going to have variable conditions here for a while, as this moisture is deflecting off of this massive air. And the reason that we call the dry air massive air, folks, is because N2, otherwise known as atmospheric nitrogen, is more massive than water vapor. So the more moist the air is, folks, the lighter it is. And that's a little bit about atmospheric physics for you. Next, another reminder as we get into value-added services to check out smashomash.com/forum. The sun, more about it. Read the article, 10 Amazing Discoveries About the Sun from NASA SDO. What are they? Well, we'll show you a couple as teasers. Fantastic flares, solar tornadoes, giant waves, combustible comets. It's a SciTech Daily article. And we have put the thing in its entirety at smashomash.com/forum. Let's talk about more bonus features. Here are the transient X-ray emissions of Sagittarius, A star. The core of the Milky Way galaxy, believed by mainstream astronomy to be a supermassive black hole. We'll just call it a massive radio source on this channel. There are the transients, and if you'd like to view them yourself, just check out the Neil Gorell Swift-Bat Observatory, which we'll link below the video. Click Control-F, type in SGR space A, and there you have it. Let's look at some more transients. How about the Vela Pulsar? And let's see what the Vela Pulsar's been up to, which is way off to the right if you're looking at the Milky Way. Nothing too exciting going on there at the Vela Pulsar. Next we'll look at Cygnus A, otherwise known as 3C405. And this is the strongest radio source in the sky besides the sun. There are the transients from Cygnus A, massive radio galaxy located about 500 million light years away. And last but not least, at all, we'll look at Cygnus X-3, otherwise known as Deneb, the massive X-ray binary that is ramping back up. So we're very interested in radio astronomers and other folks with access to sophisticated telescopes to start studying this as its transients increase. As it just left its ultra-quiescent period, you can see here's the zero line on the last couple of weeks. And here's the zero line for its historic behavior. This will be a very interesting high-mass X-ray binary to study. One of the most interesting and one of the most consistent and obvious sources of cosmic rays known to man. And again, we will leave links to the Neil Gorell Swift Observatory. Our regular viewers are more than familiar. And last but not least, we've got a 48-hour image here, a 48-hour video of the sun in 131 angstroms. This is the other instrument that takes 10 photographs per minute instead of only 2, in addition to the 94 angstroms. So we are out. Thanks for tuning in. Remember, stare at the sun, don't drink, and if you do, don't drive. And since it'll never be now again, may that solar wind be at your back, and that atherosclerosis absent from your artery.